Hi everyone, it's Shane and I'm a solution architect at Red Hat. Now in a previous video I looked at creating and managing signed container images and how we can inject container signatures into software development processes using some of the tools available from the Sigstore project. Now specifically in that video we used cosign, you can see running here, to create signatures for those container images. And then we used Record to be able to sign metadata and provide a signature transparency log so that we can see who is creating signed artifacts, how they're being created, and what kind of artifacts are being created through those processes, and provide visibility into those container signatures. What I wanted to look at today was extending that model and looking at how we can validate container signatures and look at ensuring at deployment time that the code we're looking to run has come from a trusted entity. So in this case, we're going to look at verifying and validating container signatures before we permit workloads on our cluster. Now to do that, I'm going to use a platform called Red Hat Advanced Cluster Security. And Red Hat Advanced Cluster Security for Kubernetes allows me to secure Kubernetes clusters. So you can see here I've got one cluster currently being managed, which is an OpenShift platform. And essentially it allows me to create a number of policies I can use to enforce security posture across those clusters. Now what we're going to look at today is creating a new policy that validates container signatures before permitting code to run on the platform. Now the first thing we need to do there is create a signature integration. So this allows me to specify the public key that should be used to verify signed container images. So we're going to select new integration and I can specify the integration name. Here I'll just call it Tecton Cosign, and I can add that public key. Now in the last video, we created that key as a secret in Kubernetes, and we injected that into our Tecton chains pipeline to sign container images. So what we need to do is just grab that certificate from that Kubernetes secret. So here I've got that Kubernetes secret created in our OpenShift pipelines namespace. And I'm specifically looking for that cosign.pub value. So all we have to do to get that secret is take this value and decode it. And now I've got the public key that we've used to sign those container images. So all I need to do is add that into my integration. And save it off. And now we've got that cosign verification method created inside Red Hat Advanced Cluster Security for Kubernetes. The next step here is to create a policy. So I'm going to select Create Policy, and I'm simply going to call this Signature Validation. And we'll give it a severity of medium. We'll select our category as Security Best Practices. And the description here is that all container images need to be signed. We'll select Next. Now this policy applies to the deploy stage of the application lifecycle. And in this case, we're going to inform and enforce, so that if we find container images that haven't been signed, we want to look at ensuring that that code isn't running on the platform. So we've got that enforce and on deploy applied to the deployment phase of the application lifecycle. Now the criteria we have here is that we want to look at containers that are not verified by trusted image signers. So here I'll select our Tecton Cosign integration. And in this case, I'm going to create an inclusive policy. We're going to only enforce this for this log4shell namespace in my cluster. The policy looks good. Let's create it. And now this policy is being enforced across that managed cluster. So let's look at testing out that policy. Here I can look at creating a new application inside the log4shell namespace. We're going to deploy a new container image. In this case, it's Quota.io, smiley fritz, latest. So let's give that application a name. We'll specify we don't want to create a route for now, and we'll create that application. So what you'll see is that those pods that are created from my deployment are immediately destroyed. And if I go through and have a look at closer at the deployment, you can see we have currently no pods with this deployment. And in the events, I can see the reason is because that deployment violated that signature validation policy that we just created. And all of those pods were scaled down. Now I can also see this in the Red Hat Advanced Cluster Security for Kubernetes platform. I can have a look at those violations, and I can see that that signature validation policy has been violated. We can specifically see that that container log4shell app that we created is unverified. And in this case, the deployment was scaled down to 0 replicas as that policy was violated. And we get some links back to that signature validation policy also. So this has been a really quick demonstration of how we can extend that model where we were creating signed container images and then look at validating container signatures at deployment time and essentially building out that trusted software supply chain by validating container images have been created by trusted parties. Thanks.